the deepest points of the world's 5 oceans. And all of this requires this brand new submarine.
7 miles beneath the Pacific Ocean lies a place so dangerous that, in more than 65 years, only a handful of people have ever reached it. In 1960, when Jacques Piccard and U.S. Navy Lieutenant Don Walsh attempted to reach its bottom for the very first time, they barely survived the journey. Under pressure strong enough to crush steel, their submersible began making terrifying sounds. Then, a loud crack echoed through the vessel. Somehow, they made it back alive, and the world celebrated the mission as a historic success. But to the engineers who knew, it was the biggest warning. For the next 52 years, not a single person dared return to the deepest place on Earth. And when explorers finally did go back in the 2000s, they found a world far stranger than anyone imagined. So what exactly is hidden at the bottom of the Mariana Trench? And what makes going down there even more dangerous than traveling into space? To answer those questions, we need to go back to the mission that started it all. The dive that became a warning. January 23, 1960. That morning, Swiss engineer and explorer Jacques Piccard and U.S. Navy Lieutenant Don Walsh prepared for something no human had ever done before. Their destination was Challenger Deep, the deepest known point on Earth, nearly 7 miles beneath the Pacific Ocean. To get there, they climbed into a tiny steel sphere attached beneath an unusual deep-sea vessel called the Trieste. It had been designed by Jacques' father, Swiss physicist Auguste Piccard, and looked nothing like a normal submarine. The cabin was barely large enough for 2 people. Once they climbed inside, the heavy steel hatch was bolted shut, and from that moment on, there was no emergency exit and no rescue waiting below. But reaching the bottom wasn't just a matter of building a tougher submarine. At that depth, the pressure climbs to almost 16,000 pounds per square inch, more than 1,000 times what we experience at sea level. An ordinary submarine would never survive it. So Auguste came up with a solution that sounded almost unbelievable. Instead of using air to stay afloat, the Trieste's massive upper section was filled with more than 22,000 gallons of aviation gasoline. Why gasoline? Because it's lighter than water, and, unlike air, it barely compresses under extreme pressure. That meant it could still keep the vessel afloat nearly 7 miles below the surface. To sink, the Trieste carried nearly 9 tons of iron pellets held in place by powerful electromagnets. If the power ever failed, the magnets would automatically release the iron, making the vessel light enough to slowly float back to the surface. In other words, every part of Trieste had been designed around one simple goal: keeping the 2 men alive in a place where no human had ever been. For nearly 5 hours, the descent went exactly as planned. Then, at around 30,000 feet, a deafening bang ripped through the vessel. The entire craft shuddered. For a few terrifying seconds, neither Piccard nor Walsh knew what had happened. If the main pressure sphere had cracked, there would have been no warning and no chance to escape. Only later did they realize the damage was limited to the outer plexiglass viewport of the entry tunnel, where extreme cold and enormous pressure had stressed the material until it fractured. Even then, there was no easy way out. A safe ascent would still take hours. The only real option was to keep descending and hope the damaged window held. Almost 5 hours after leaving the surface, the Trieste finally settled onto the floor of Challenger Deep, about 35,800 feet beneath the surface. The 2 men stayed there for only about 20 minutes before beginning the long journey back. After a slow ascent that took more than 3 hours, the Trieste finally returned safely to the surface. Officially, the mission was celebrated around the world as a historic triumph. Humanity had finally reached the deepest place on Earth, But behind the headlines, engineers saw something far more terrifying. Two men had spent more than 8 hours sealed inside a steel sphere, trusting it to hold back nearly 7 miles of crushing ocean. One viewport had already fractured, and if another critical part had failed, there would have been no escape and no way to save them. The mission had succeeded, but only by the narrowest margin. They hadn't conquered the Mariana Trench. They had survived it. And that single dive changed how the world looked at the deepest part of the ocean. Instead of opening the door to regular exploration, it convinced many that the risk was simply too great. That's why, for the next 52 years, almost nobody was willing to take that gamble again. 52 years of silence. If the Trieste mission had been a success, it should have opened the door to a new era of deep-sea exploration. Instead, it did the exact opposite. After 1960, no one returned to Challenger Deep for the next 52 years. It wasn't because scientists stopped caring. The real problem was that getting back there required solving 3 of the hardest challenges. The first was the machine itself. The first obstacle was simply building a machine that could survive the journey. It wasn't just expensive, it demanded near perfection. At those depths, even the smallest flaw could destroy the vehicle before it ever reached the ocean. But even if engineers built the perfect submersible, there was another problem. If something went wrong at the bottom, there was no rescue. Unlike astronauts in orbit, there were no rescue submarines capable of reaching 36,000 feet. If a sub became trapped or lost power, the crew would be completely on their own in freezing darkness. There was no backup plan, no emergency team waiting below, and no realistic way to bring them home. Then there was the third obstacle, timing. The Cold War had pushed the world into the space race. Rockets, astronauts, and the moon captured global attention, and television moments watched by millions. Deep-sea exploration offered none of that. From the surface, all anyone could see was a ship lowering a steel vessel into black water, then waiting for hours. It was harder to explain, harder to fund, and far easier to ignore. So, for exactly 52 years, Challenger Deep remained almost untouched. Then, in the 2000s, that silence was finally broken, not by a government agency or a navy, but by private explorers willing to pay a price governments no longer wanted to. And the very first person to take that risk was someone the world already knew, but for a completely different reason. The return to the abyss. On March 26, 2012, one of the world's most famous filmmakers, James Cameron, decided to do what no one had dared attempt for more than half a century. He climbed into a one-man submersible called the Deep Sea Challenger and began the long descent toward Challenger Deep. Unlike the bulky Trieste from 1960, this vehicle was tall and narrow, almost like a giant underwater torpedo. It was even designed to slowly spin as it descended, helping it cut through the water more efficiently and reach the bottom faster. But its biggest breakthrough was hidden inside the hull. Instead of using thousands of gallons of gasoline for buoyancy, Cameron's team spent years developing a completely new material called isofoam. Filled with millions of microscopic hollow glass spheres, it could withstand the crushing pressure of the trench, while also keeping the submersible afloat. After 2 hours and 36 minutes of descent, Cameron became the first person to reach Challenger Deep alone. He spent nearly 3 hours on the seafloor, capturing the first high-definition video ever recorded from the deepest point on Earth, and collecting valuable samples for scientists. But the trench reminded everyone that it hadn't become any safer. During the dive, a high-pressure hydraulic line ruptured. Cameron made it back safely, but the mission ended earlier than planned. The deep-sea Challenger had proven that humans could return to the bottom, yet it was too complex and fragile to keep making dives. After that historic expedition, it was retired and later donated for scientific research. For a moment, it looked like history was repeating itself once again. Then, 7 years later, another private explorer approached the trench with a very different goal. Victor Vescovo, a businessman, explorer, and former U.S. Navy officer, didn't just want to prove a single dive was possible. He wanted to make reaching the deepest place on Earth almost routine. His submersible, the DSV limiting factor, was built around an almost perfectly spherical titanium pressure hull. And unlike every vehicle before it, it wasn't built for one historic mission. It was built to keep coming back. In 2019, Vescovo reached Challenger Deep not once, but 4 times in just 8 days. His team also created the most detailed maps ever made of the trench. In a way, these 3 missions changed deep-sea exploration forever. Picard proved humans could survive the deepest place on Earth. Cameron proved we could return. Vescovo proved we could keep coming back. And those repeated trips changed everything. Because now, scientists could finally stop worrying about simply reaching the bottom and start asking a far more important question: what exactly was hiding down there? And the discoveries that followed would challenge long-held scientific ideas and reopen one of the biggest mysteries on Earth: the impossible life. The first discovery that truly changed the conversation came in 2019. An international team of researchers collected water and sediment samples from more than 10,400 meters below the surface and analyzed the tiny traces of DNA hidden inside them. Their results, published in the journal Microbiome, revealed something nobody expected. The deepest part of the Mariana Trench was packed with bacteria that survive by eating hydrocarbons, the same kinds of chemical compounds found in crude oil. That alone was mind-blowing. But what shocked scientists even more was the sheer number of them. These oil-eating microbes were found in higher concentrations than anywhere else ever recorded in nature, even higher than on heavily polluted coastlines and major oil spill sites. But that raised an even bigger question: where was all that oil coming from? At first, researchers feared it was another sign of human pollution slowly sinking from the surface. But when they examined the chemical fingerprints of the hydrocarbons, the story became much stranger. The evidence pointed to a natural source deep inside the trench itself. Because the Mariana Trench lies on a massive subduction zone where one tectonic plate slides beneath another, natural geological processes can release methane and other hydrocarbons from deep inside the Earth. But those microbes are only the beginning. The seafloor is also home to strange giant single-celled organisms called xenophyophores, along with shrimp-like amphipods that have evolved pressure-resistant bodies. Then there's the mysterious Mariana snailfish, the deepest fish ever filmed. Its soft body and unique chemistry allow it to survive where almost every other fish would be crushed. Now, the discovery of these unusual organisms, and especially oil-eating bacteria, proved that life could survive without sunlight. But that raised an even bigger question. If sunlight wasn't powering these ecosystems, what was? The search for that answer led scientists to another part of the Pacific, where they stumbled onto a discovery that challenged one of biology's oldest rules: the oxygen paradox. Back in 2013, Professor Andrew Sweetman of the Scottish Association for Marine Science was studying the seafloor in the Clarion-Clipperton Zone, a vast abyssal plain between Hawaii and Mexico. His team placed sealed chambers on the ocean floor to measure how quickly deep-sea organisms used up oxygen. The result should have been simple. Inside a sealed chamber, animals and microbes breathe. With no sunlight and no plants producing fresh oxygen, the oxygen level should slowly fall. Instead, it kept rising. At first, Sweetman thought the instruments had failed. The readings seemed so impossible that he set them aside, convinced they were nothing more than a technical error. But the numbers refused to go away. Over the next several years, his team returned with newly calibrated equipment and repeated the same experiment again and again. Every time, they saw the same pattern. Somehow, oxygen was being produced in complete darkness. In 2024, the team finally published its findings in Nature Geoscience. The most likely source wasn't a living organism at all. It was polymetallic nodules, potato-sized rocks scattered across the seafloor. Some of these rocks carried an electrical charge of nearly 1 volt, almost as much as a household AA battery. Even more surprising, groups of nodules appeared to work together, creating enough electricity to split seawater into hydrogen and oxygen through a process called electrolysis. The researchers called it dark oxygen because it seemed to be produced without sunlight. If confirmed, the discovery would challenge the long-accepted idea that new oxygen can only be produced through photosynthesis. But that's exactly where the debate began. Many scientists agree that the oxygen readings are real. What they continue to debate is the explanation. Some believe the oxygen may have come from the research equipment itself, rather than the rocks. Others argue there still isn't enough evidence to prove the nodules can generate electricity over long periods. But whether every detail of the explanation holds up or not, these discoveries have already changed how scientists think about the deepest parts of our planet. For years, researchers believed the deepest ocean was little more than a cold, dark place where life barely managed to survive. Instead, they found thriving ecosystems powered in unexpected ways, and evidence that oxygen itself might be produced without sunlight. In other words, the deeper we looked, the more the old rules began to break. But here's the thing. While scientists are still trying to understand what other secrets the deep ocean may be hiding, something else is happening at the same time. Metals needed for electric vehicle batteries and other modern technologies. Mining companies see them as one of the world's biggest untapped resources, and that creates the biggest tension. Because according to scientists, if these nodules really play a role in supporting deep ocean ecosystems, removing them could damage an environment we still barely understand. More than a decade after the first strange oxygen readings, the debate is still far from settled. But that's only part of the story. Because the truth is, mining companies aren't the only ones interested in what lies at the bottom of our oceans anymore. Why does NASA care? Why would a space agency care about the deepest part of the ocean? The answer is surprisingly simple. Because, in many ways, the deepest part of our ocean may be the closest place on Earth to another world. Scientists believe 2 icy moons in our solar system, Europa, which orbits Jupiter, and Enceladus, one of Saturn's moons, both hide vast oceans beneath thick layers of ice. Those oceans have never seen sunlight, just like the deepest parts of Earth's oceans. Yet there's growing evidence that they may not be lifeless. That idea became much more exciting in 2017 when NASA's Cassini spacecraft flew through enormous plumes of water erupting from cracks in Enceladus. As it passed through those plumes, its instruments detected organic molecules, exactly the kinds of chemical ingredients scientists expect to find around hydrothermal vents. In other words, the conditions beneath that frozen ice may be surprisingly similar to the extreme environments found deep beneath Earth's oceans. That's why NASA doesn't just study space. It also studies the deepest parts of our own planet. Working alongside organizations like NOAA, the Ocean Exploration Trust, and companies such as Subsea Imaging, researchers use Earth's deepest oceans as a testing ground. They develop autonomous underwater robots, test life detection instruments, and study strange ecosystems that exist without sunlight, because those same technologies may one day explore oceans hundreds of millions of miles away. Even Europa Clipper, which launched in October 2024 and is expected to arrive at Jupiter in 2030, was designed with that goal in mind. Rather than landing on Europa, it will make dozens of close flybys, mapping the moon's icy shell, studying its hidden ocean, and searching for the chemical conditions that could support life. And if you think about it, it's remarkable. A mission that nearly ended in disaster back in 1960 eventually pushed scientists toward discoveries that reached far beyond our planet itself. Today, every new expedition into the deep ocean helps scientists understand how life survives under conditions once thought impossible, knowledge that could one day guide the search for life beyond Earth. In other words, the first step toward understanding the universe is exploring the hidden world beneath our own feet. So, here we are. For more than half a century, the Mariana Trench has reminded us how little we still know about our own planet. Even today, only a handful of people have ever reached its deepest point, and almost every journey has challenged something we thought we understood. Now, after hearing the whole story, what surprised you the most about the Mariana Trench? And if we've explored more of the moon than the bottom of our own ocean, what do you think we're still missing? Let me know your thoughts about this in the comments below. If you enjoyed this video, don't forget to give it a thumbs up. And if you want more incredible mysteries, discoveries, and fascinating stories like this, be sure to subscribe to the channel. Thanks for watching, and we'll see you in the next video.